Okay, so this is 6-8, and it's a very short lesson, and will be completely honest with you. It's not something that you use quite a bit in math, and a lot of times I actually have skipped this lesson in the past, but I thought I better go ahead and explain to you what some of this is in case you see these formulas again. So we're going to talk about now the recursive formula. So there's two formulas when we're talking about sequences, arithmetic and geometric. So both, that's again when you're adding or subtracting. This is when you're multiplying. It looks like division, but technically you're multiplying by a fraction. But the sequences, there's two types. And I should have told you in 6-7, this is what you've been working on, meaning you finding the nth term. That one is more useful of the two. But I thought I'd go ahead and just share because I did look ahead at the, anyway, your end of course test. Not at the test because I can't see those, but the formula sheet that you're able to use. And so I wanted to just explain, if you see this, what it would look like and what that means. Now, recursive rule. Recursive, by definition, that is something that is, it's adding over and over again, or maybe subtracting over and over again, but it's whatever the rule is, it's happening, I don't even know if I'm over and over again. It's not the actual definition, but that's kind of what that means. It's recursive, meaning it's repetitive. Actually, that's what I should have wrote, repetitive. But, so here's what you need to know. The first term in the sequence, either A or G. Now remember, A is your arithmetic, G is your geometric. Then you need to know the pattern rule to get to any term in the sequence from the term becomes means this A of n. So let's say we need the fifth term. And then you also need the common difference. So you need to know the term you're starting with. You need to know the common difference. Okay, this one, right, I even emailed the high school teacher too. I go, okay, I'm not understanding what this is. So I'm just going to ignore that for now. And then the geometric one, again, it's the geometric one, so you need the common ratio. Remember the R's, their common ratio? Meaning, what are they multiplying by? Okay. So here's what, the only thing that I don't like about this is though you have to know all the numbers in sequence to know the fifth one. So it really doesn't save you much time. So let's say here, write the first 6 terms of each sequence. Well, if our A of 1, if our first term is 2, that's our first term. Then what this is saying, this 3 is your difference. You're adding 3 to each term. Well, you need to know your first term. You're adding 3, so that's going to be 5. You're adding 3, that's going to be 8. It's going to be 11, be 14. What do we need? The first 6 terms, 1, 2, 3, 4, 5, and then 17. So it doesn't, this just means you have their first term, what you're adding each time. Okay. This one is going to be, your first term is 1. And then, I can't tell what that is. Does that say, oh, the previous term, oh, this is the previous term times 3 minus 1. Whew. Okay, so what you're doing here, previous term. So what's happening here is this is saying 3 times A. Oh, this is going to be confusing. Anyway, I don't know if this is going to be worth it. So 1, okay, so 1 times 3. Oh, no, this is not minus 1. This is subscript n minus 1. I am sorry, you guys. So this is just, you're just multiplying this by 3. So I don't know if that would be arithmetic. This is going to be geometric. I think this needs to be G of 1. We're going to erase this. We're going to change this. This should be G of 1. So 1, 3, 9, 27. That's a geometric sequence. That's a geometric sequence. How many terms? 6. 81 times 3 is 243. So this should be geometric. Sorry about that. All right, now write a recursive rule for each of the sequences. Now writing one. So we have to think of it. First of all, we need to know where we're starting. So this is your A sub 1, meaning you're starting at negative 30. Then we need to know, it's going down, so are we subtracting or are we dividing? Okay, this looks like this is, oh, actually we're adding. This is adding 12. Adding 12, adding 12, adding 12, adding 12. So our common difference, our D, is adding 12. So our rule is going to look like this. So we have A sub n equals A n minus 1 sub the subscript plus 12. And then A sub 1, like we need to know A sub 1 equals negative 30. You need to know that because you need to know where you're starting. Then this one, you can tell here, this is going down and it's dividing by 5, which means you're multiplying by 1/5. So this is a geometric. So your geometric sequence. So the first term is 500. Then, since you're multiplying by 1/5, you're going to have G of n. The ratio is 1/5. And then you're going to have G subscript n minus 1. So you need all of this information. And really that's it with recursive. This is not really that useful because you need to know all the previous numbers in order to get to the next one. So the recursive rule, I'll be honest, is not very useful. At least not in Algebra 1. Maybe it's in Algebra 2. But explicit rule is the one we'll use most. But I thought I'd go ahead and share that with you, at least what this is saying here. Okay, hope that helps.